All right, so here's some examples of how we use the Pythagorean identity. All right, so our first example, we have the point 4, 3. And it says let 4, 3 be the point on the terminal side of theta. And they want us to find the exact values of sine, cosine, and tangent of theta. All right, so the first thing we want to do is we want to draw a triangle, but we want to make sure it's in the correct quadrant. And since we're dealing with the point 4, 3, we know that 4, 3, the x and the y are positive, and so that means that point must lie in the first quadrant. And so if I take my coordinate grid, I can plot the point 4, 3 approximately and label that off. Now, once you plot that point, you want to connect the triangle coming from your origin out to that point. And you always want to drop your perpendicular down to the x-axis. Like, I'll never drop it to the y-axis. Everything is always dropped. No matter what quadrant I'm in, I drop it to my x-axis. All right, so if that's my point, I know that my horizontal distance is going to be 4, and my vertical distance is going to be 3, and then I have that angle of theta coming out of the origin. All right, so the second thing I want to do is I want to use Pythagorean's theorem to find the third side. In this case, our third side that we're missing is the hypotenuse. And so using Pythagorean's theorem, I have a squared plus b squared equals c squared. My a and my b are 4 and 3. It doesn't matter which order you put those in. And so 4 squared plus 3 squared is 16 plus 9. 16 plus 9 is 25. So c must then be 5. Now, technically, c is plus or minus 5. But because c is the hypotenuse, your hypotenuse always has to be positive. So I know that my hypotenuse is 5. And then I just throw that into my triangle to complete my triangle off. All right, so now that I have a completed triangle, we want to lastly use SOHCAHTOA to find the values of sine, cosine, and tangent of theta. And so again, looking at my triangle, if I wanted to find sine theta, remember that sine theta is opposite over hypotenuse, so that's 3 over 5. Cosine theta is adjacent over hypotenuse, so that's 4 over 5. And then tangent of theta is opposite over adjacent, which is 3 over 5. All right, in example 2, very similar example, we have find the exact values of sine, cosine, and tangent if they give us that secant is 6/5 and tan is less than 0. So again, the first thing I want to do is draw a triangle in the correct quadrant. Now, because secant is greater than 0, is 6/5, and tan is less than 0, so secant is positive or cosine is positive and tan is negative, theta must be in quadrant 4. So again, I'm going to draw my triangle in quadrant 4, representing the value of secant. Now remember, secant is hypotenuse over adjacent, so my hypotenuse is 6 and my adjacent is 5. Now remember, the hypotenuse always has to be positive, so even if secant was negative, the negative would have went on the 5, not on the 6. All right, next we're going to use Pythagorean's theorem to find the third side. So here's our triangle. We have a squared plus b squared equals c squared. Our a is 5, our c is 6. So we have 25 plus b squared equals 36. B squared equals 11, or b equals the square root of 11. Now remember, b is technically plus or minus 11. And because we're in the fourth quadrant, I want my b to be negative because it's going down on the y-axis. All right, so I throw that into my triangle, and now I have a completed triangle. All right, lastly, we want to use Pythagorean's theorem to find the sine, cosine, and tangent. And so remember, sine is opposite over hypotenuse, so that's negative square root 11 over 6. Cosine is adjacent over hypotenuse, so that's 5 over 6. And tangent is opposite over adjacent, so that's negative square root 11 over 5.